But the short reason, I think, is we found parameter sharing to not be helpful because you basically just want to reduce your loss as efficiently as possible, and you have sort of as much data as you could ever need, and there isn't much of a generalization gap.
Also reminiscent of VIT, surprised everyone that it did so well compared to CNNs. But final question, we were talking about this in the car on the way over, Andrew. The elephant in the room is that GPT-5, we have all these huge over-parameterized models, and on the surface, they seem to be doing very well. They're benchmaxing and they're brilliant to use, but it feels that there's something missing. I mean, I think they're not intelligent. I believe you would agree with that statement. What's missing and what's next?
So one of the things I'm most excited about is developing AI systems that can discover new scientific theories at the level of general relativity or quantum mechanics. And we haven't even really scratched the surface in being able to do this. It's not even clear how data-driven that process would be, how much it would look like symbolic logic if we were to think about what Einstein did when he proposed relativity and how we might want to write that down as an algorithm and automate it on a computer. And so I would love to see progress in this direction. I think that some of the ideas that we've discussed around compressibility could play an important role in how we think about selecting for scientific hypotheses. Also, ideas around universality, like what sorts of assumptions might be more universal than others and at what level of abstraction. But it's something that we haven't really made progress on at all, despite a number of very exciting research projects in AI for science, where neural nets, for example, are being used as black box function approximators in some sort of pipeline targeted at a very specific application. And I think this is extraordinary work, and it's really a way in which machine learning is clearly doing a lot of good in the world. But I think it's time to try to go beyond that paradigm towards really giving us new scientific insights into the data that we didn't have before. And in fact, that's something that I'm really more excited about than anything else in terms of how technology might develop in the future. Like if I were to go 1,000 years in the future, one of the first questions I would have is, well, do we understand something about physics that we didn't before? Do we understand how the brain works? And this is sort of a conventional sort of like approach to science where the theory is really the quantity of primary interest, and the applications, of course, are important, but they're not primarily why, like no individual application is primarily why we care about the theory. Like GPS would break within minutes if we weren't accounting for gravitational time dilation and general relativity. But Einstein wasn't thinking about GPS when he proposed relativity. And if you have the theory, then you can sort of suggest all sorts of applications that otherwise wouldn't have been on the horizon. And like we probably could train a neural network to correct for gravitational time dilation without understanding what's going on. But that wouldn't be nearly as exciting or useful as having the theory of relativity.
Yeah. Professor Wilson, thank you so much for joining us today. It's been amazing.
Thanks so much. It's been a real pleasure.
If you want to learn more about this work from Andrew, please check out the paper Deep Learning is Not So Mysterious, also their paper Bayesian Deep Learning and a Probabilistic Perspective of Generalization, which also discusses Bayesian principles in deep learning, and also their recent paper Compute Optimal LLMs Provably Generalize Better with Scale. That has further analysis on the source of the simplicity bias arising from scale. Cheers.
At Google, and my work has been mainly around application modernization and emerging technologies. I'm an active conference speaker, and generally I've been speaking around Kubernetes, platform, distributed systems, and DevOps SRE landscapes. As I mentioned, today's session is going to focus on GK Inference Gateway. This is a recent addition to the GKE stack. And in case you have any questions, feel free to chime in or probably raise your hand or write on the chat box. So they will be helping us moderate the session. If we see a lot of questions coming through, we'll be taking those questions towards the end of the session in a dedicated Q&A. The length of the session is roughly going to be 30 to 40 minutes. And just a disclaimer that we are going to discuss about some of the stuff which might give you an impression that we are talking about performance gains, etc. The intent of this particular session is not to advertise/evangelize or sell any specific performance gain related functionalities or products. It's just for understanding what exactly happens when we are serving workloads on Kubernetes and how exactly they look like when we have them served through Google Kubernetes Engine, what all features we have. So this is more of an awareness and knowledge augmentation session than selling anything. So don't take any of the views presented here coming from Google, take them coming from my experience. So it's all personal stuff that I'm going to talk about. So let's get started. We need to understand that these days, a lot of hype is there around AI. A lot of people are investing in research as well. So some people are really thinking it from a perspective that AI is going to change a lot of things. And some of the people are just trying to get close to the hype and they are trying out new kind of things. Ultimately, what happens is that for the people who are really interested in serving AI workloads, they are trying to find how we can have cost optimization done for serving AI workloads, how we can have performance gains, how we can do some sort of intelligent routing so that we can have effectively we can have effective inferencing or serving of the AI workloads done, etc. So this is where we see that the trends are changing. AI workloads are no longer or cannot be treated as workloads like regular web applications. So we need more or less this particular thing or the first objective to be met as part of the AI serving model from our side, which is self-hosting. Because you see that when you go ahead and try to go over some platform as service or SaaS related AI serving functionalities or products that are there, they generally tend to cost more when you try to get more traffic or more load. This is where you think of probably having some self-hosted generative models hosted on, let's say, Kubernetes or virtual machines. And that is where we do see a need to have some sort of standardization, some sort of let's say extension processor kind of thing like we have in other gateways like Envoy to be there, which can give us an interface through which we can have proper hosting of the models done in a standardized manner. The second thing is that the AI workloads these days are going to have a lot of fresh requirements also pouring in. Some of the common requirements that we have seen in the past include latency sensitivity. So people are generally looking for more real-time experience with workloads. So you see that when you are interfacing with a chatbot, your expectation is that your response gets served as soon as possible or in a jiffy, as in when you type in some prompt, you are expecting the response from the chatbot. However, when we come to, let's say, deep thinking related use cases, in that case, you are not really bothered much about latency sensitivity. You are bothered more about the context length, and also if you can have good information served in form of output, or like detailed information served in form of output. So latency sensitivity is something that we have to generally deal with. Also, context window length is something that we need to deal with. So this is completely, I would say, fresh from a perspective if we were to consider it as an application developer, a regular web application developer getting into AI model serving. Then we do have some advanced load balancing requirements. Generally, you see that you open some host application or desktop application wherein you have to interact with the LLMs. Sometimes you see that you provide a big prompt, and ultimately you see that the model was not able to serve, or there was an error that, okay, we were not able to produce results. And ultimately you have to wait for some time and reattempt submitting your prompt. And after a couple of attempts, you see the response coming, but you have to wait. And until then, you keep on seeing errors. Then there is something called as model-aware routing or model serving priority. So generally, in industrial applications or enterprise applications, you won't be relying on just one single model. You ideally would be looking at a bunch of models. So you would want model, let's say DeepSeek for doing some recommender stuff. You would want Gemma to do some text-based stuff. You would want some other image-specific model to do some image manipulation, or let's say captioning of image, etc. So this is where you could be having the same endpoint, but that endpoint could be having different behavior getting executed based on the models that are getting selected. Sometimes it could be payload or body specific, wherein you could be just focusing on one modality, let's say text only, but you could be saying that, okay, I want the response from Gemini, and I want the response from Claude, and I want the response from some other model. And probably the model criteria should be that based on some specific identifier, like the person requesting or the user agent requesting for inference, or let's say the company which they belong to, or the region which they belong to, or any kind of payload information or query parameter field could be there, based on which you want to do some payload based or body based routing. So this is where it could either be a model based routing, or a body based routing, or a model aware routing, and it can be dynamic as well, like on the fly when the request has been submitted, then the decision gets taken as to which model needs to serve. Because sometimes it could happen that your model behind the scenes has got the tokens exhausted, it has probably hit the quota that it was defined with, and now you cannot really have the users suffer because of the quota getting exhausted. So you have a fallback model on which you want to go, and you want to serve from that particular model. So such kind of things generally are part of a body aware routing, or a model payload based routing, or let's say tokenization that you can enforce for LLMs, etc. And based on that you want to do routing. So there are some capabilities which can be dealt with via Kubernetes only, based on the Kubernetes extension model or the inference extension model that we are going to talk about today. Some of the capabilities are better fit for service by something called as model as a service provider. This is a new again term that has come, model as a service provider. So you would have heard about management solutions or API gateway management solutions like Apigee, like LLM Lite, or like Envoy AI Gateway, Kong, and all. So this is where these model as a service providers can complement what Kubernetes is serving, and can help us with things like LLM tokenization, aware routing, or monetization, or analytics insights, etc. So we are going to touch briefly upon those things as well towards the end of the session. Then comes A/B testing, canary testing, any kind of testing that you would want to do. So this is where you are deploying a model, you want to deploy a new version of the model after you have incorporated the feedback. This is where the A/B testing thing comes into picture, and you want to do some traffic splitting. It could be percentage based, it could be weight based, it could be based on some other factors. So this is where you already see that, okay, this has some commonality with the regular ingress or the gateway features that we were using with Kubernetes, but now it has something more to do with respect to models specifically, because it is no longer a normal application. It has stuff related to the underlying resources getting utilized, which are no longer just CPU and memory. We have GPUs, we have TPUs, we have some other tangible resources as well. Ultimately, we come to a point wherein a lot of people these days who are creating self-hosted generative models are under resource crunch. Many times it happens that you have single GPU which is on a host, and that GPU needs to be shared by multiple tenants. Now, sharing is something which by default in GPUs is not possible, because GPUs don't have a concept of vGPUs configured by default. So you either have to do hardware slicing that can give you isolation in terms of fault tolerance and memory. This is something that you can do using multi-instance GPU from NVIDIA, or you want to go with something basic like time slicing or MPS. These are again things which could help you realize some sort of kind of sharing of GPU, wherein at the same point of time you won't be sharing the same GPU. If it's software based, you rather would be getting access to GPUs in turns. So it's more of like time slicing or multi-process access, etc., which is sliced in some manner. And when you are doing time slicing, the context window switches so much that you generally don't get the desired performance. So this is where there are some techniques that you should be using from serving perspective, which can really help you regardless of which GPU sharing technique you're going with. And for people who are interested in further checking on the concept of vGPUs, there is a talk from me which is called Declarative Device Virtualization, that covers a specific tool called HAMI, wherein I show how you can have a software level configuration which can help you access GPUs in a multi-tenant fashion without having to get into context switching challenges, etc. So that stuff we are not going to focus much upon today, but I'm just referencing that. It's called Declarative Device Virtualization with HAMI. It should be on YouTube as well. And we generally see that GPUs and TPUs are these days getting considered as the go-to accelerators. People really don't understand when to use GPU, when to use TPU, when to use CPU. So I'm not sure what kind of experience this particular audience has, but for people who have been using precision-focused arithmetic operations, for those people, generally going with GPUs would be better than TPUs. For people who have any specific, let's say, TensorFlow operation-related dependency, a lot of TensorFlow operations are not supported with TPUs, so you will need to go with GPUs in that case. If you have any kind of linear algebra programs which are getting executed in the main loop, then also TPUs won't be fit, and you will need to go with GPUs. Where TPUs would make sense would be like long-running training cycles that are there, which probably are running multi-days or even weeks. or you have large batches of training, that is where TPUs can help. But generally, for complex logic, wherein you have precision arithmetic, or you have operations in the main loop, or you have dependencies on libraries like PyTorch or JAX operations, which are very complicated, those will generally require GPUs. So this is where GPU, TPU choice, when to use which one, all of those things are also something which are popping up as part of the inference journey. And hence, you should be having control based on some parameters, or based on some body-related understanding, or based on the model serving dynamics. You should be able to dynamically route the request to TPUs or GPUs without having for you to jump in and decide when to have such kind of thing, or without having to hard code your backend pool which is serving the pods. Then we get into this unified management for traffic policy enforcement and observability. This is where we do see that these days there is certainly a requirement to have some sort of traffic management done, not just at the level of load balancers, but also at the cluster level. So people who are using things like service meshes or multi-cluster ingress, or who have any kind of disaster recovery or high availability use cases that span multiple data centers, this is where a unified management for traffic is required. Also, we should not really ignore the security related aspects. So this is where if you want to enforce any policies, or you want to have some specific nature exhibited from security perspective, you should be looking for something which can be enforced at a blanket level, rather than doing in a point manner, cluster by cluster or service by service. And ultimately, whatever we are talking about is something which will not be possible unless we have an end-to-end visibility or any kind of telemetry for. So that's where the observability portion comes into picture. So these are some of the top requirements which made us think about, okay, why not have some standardized solution and interface which can go about having self-hosting of the generative models done via Kubernetes, because Kubernetes is getting very popular. You have a lot of these model as service providers and gateways, Nginx, K-Gateway, and whatnot coming into picture, and with MCP and A2A and A2P, etc., all coming into picture, this particular landscape is further flourishing. So with this, we get into the main, I would say, high-level resource model where the different personas fit in. So you need to understand that generally, and I'm assuming that most of the people here are already aware of the Kubernetes Gateway API, the vanilla one, not the inference one. If not, then you can just type in chat and I can give you a quick overview of the same. But this is essentially for having load balancing capabilities for Kubernetes introduced, so that you can have a layer 7 load balancing. You can intercept the payload, and you can take intelligent decisions based on what is there in the payload, or what is there in the request. This is a successor of the native ingress that used to be there in Kubernetes, and both ingress and gateway can be used on the same cluster when you are doing, let's say, migration of different use cases for different tenants. But generally, gateway is considered as a successor for ingress, unless you have very specific use case wherein your dependency is on the ingress provider, for which you don't have a gateway class. So gateways generally have a concept of classes, and with Google Kubernetes Engine, we have defined classes for external exposure, global exposure, regional exposure, internal exposure, and so on. So gateway and HTTP route together essentially help you define, okay, my request is coming, it matches so and so path, it has some headers, it has some query parameters, or it has some layer 7 behavior. According to the behavior, according to the parameters, according to, let's say, annotations, I want to route the traffic to some specific backend. Now, traditionally, if we talk about the vanilla serving model, that is where the backend used to be a service. So this service is a Kubernetes service, the regular Kubernetes service that you are just exposing in L7 capacity, like you used to do in Ingress. With this with this Kubernetes inference extension coming into picture, you have somewhat equivalent of service coming, though it is not having the network related intelligence, which is called inference pool. So inference pool, if you were to consider, inference pool is nothing but a pool of pods you can consider, or model servers or replicas you can consider, which have the same configuration, same compute type. They are homogeneous, basically. There's no heterogeneous configuration out there. They have the same base language model, and also the model server dynamics are the same, and they are powered by either GPU or TPU or CPU, depending on what the family looks like. And ultimately, this inference pool is what is a new resource which has got added as part of the inference extension for the Kubernetes gateway. And this primarily focuses on the inference use cases, along with some routing extensions, like you want to have routing done based on some priority. Let's say two concurrent requests are coming, and you want the gateway to decide which request should be served first because of some urgency or the priority that you have defined. So that is what you can define using something called as inference objective. So these are two custom resources. So CRDs for the same have got introduced as part of the GKE inference gateway, or like if you want to talk about open source, then it's called Kubernetes Gateway Inference Extension. So these two are the custom resources that have got introduced, and there are different personas now to handle these. So one is the inference platform owner persona, and one is the inference workload persona. Inference platform owner will be defining how the inference pool would look like. This is where it will be specifying the pool spec related information, what the target backend services would be, what the target port would be, etc. We'll shortly see an example of this as well in action. And the inference objective, as of now, can specify the priority, but in future there are some targets for the open source project to even have SLOs, etc. considered. So that is where it has a good future from a serving perspective. So this is how an inference pool looks like. You define it like any other Kubernetes resource, and this is the vanilla Kubernetes example that I'm giving, not the GKE specific one. Here you are specifying the name of the inference pool, and then you are specifying the target port. So what exactly happens is that this inference pool gets created. This inference pool is essentially going to target pods of an application that has this particular label selector. And if this application exists, then for that particular application, port 8000 is going to be used as the target port for routing the traffic. Ultimately, the decision that gets taken with respect to routing is essentially based on another resource which is called endpoint picker. And that endpoint picker or EPP resource is something which gets identified by the EPP service defined here, which should be exposed on some specific port. And there are failure mode related metadata configurations also supplied. Like what happens if the endpoint picker itself is not able to identify which backend or endpoint slice this particular request should be going to, then in that case, the endpoint provider will return a 429 and your request will be dropped. However, if the endpoint picker essentially gives you that, okay, this is the pod which your request should be getting routed to, and we will see what all those factors are which will be influencing the EPP's decision shortly. Let's assume endpoint picker is a service which is running, which just tells you, okay, out of these pods, this particular pod looks to be free right now, let's route the request there, or this particular pod seems to have the required model, I'll serve it from there. Such kind of decisions get taken from EPP layer. And there is another component which is the BDR component, or body-based routing component, that works in conjunction after the request has been received at the gateway with EPP. The body-based routing decision controller decides if there are any body-specific routing logic or routing decisions that need to be taken, and ultimately then your inference pool gets selected to which the request needs to get routed, and a specific part of that needs to serve the request also gets identified. So overall, like if I have to sum it up from inference pool perspective, and probably there is some issue with the delay with the streaming, so I think the images are getting loaded in a delayed manner. But if you have to do kind of a comparison, this is the Venn diagram showing the common area. So between inference pool and service, the commonality is that you are able to have pod selectors and port configuration specified for the targets that you want to have for your model serving. However, there are differences, like inference pool is not really meant for doing network operations. Like it doesn't have the DNS records, it doesn't have the load balancing capabilities in its own. It is just meant for having the identified pods routed towards, and then ultimately it's something which is very specific for inference use cases. It's not really meant for any protocol specific lower level operations, nor it is meant to be used with any CNI or container network interface plugins, etc. Okay, so let's get into the entity relationship at a high level as to how it looks like. So we are now going to understand how many backend services or let's say pods can be reached out from the inference pool, how let's say backend references interact with the inference pool, what's the relationship between an inference pool and inference objective, and such kind of thing. So let's assume you have a gateway which has an HTTP route with 3 backend references specified. There could have been multiple HTTP routes, but for brevity purposes, I have kept it like this. And specifically, you are having one backend reference point to the inference pool. Inference pool essentially has this endpoint picker bundled along with it. So there is a one-on-one relationship for this particular inference pool and this particular inference pool. That's why I have labeled it as EPP2 and EPP1 respectively. And you see that there are multiple backend references that could be pointing to the same inference pool. This could be because probably we are doing some sort of transition or we are doing some maintenance activity and we want to have this particular backend reference get 90% of traffic and this get 10% traffic, or probably this backend reference has got some other annotation or label or probably some metadata that needs to be floated, which actually was met as part of the HTTP route configuration. And that's why we are also routing it to the same inference pool, because ultimately the model that needs to be served, the configuration that needs to be served, and the compute classes, etc., that are there, those match what are needed for inference pool 1 as well. So basically, inference pool backend remains the same for the 2 backend references, but the backend references related metadata and configurations could be different. Then you have you can actually have different inference objectives attached to the inference pool. So like here we are having 2. So objective 1 is actually serving different set of requests. Probably it has a different priority defined, and then objective X has a different priority defined. But ultimately, if you are passing a header in your request which explicitly is defining which particular priority I need to go with, like there are specific headers also that you can pass on from the upstream, then in that case you will have these 2 inference objectives work well with the inference pool 1. However, inference objective X won't be applicable to inference pool 2 because there is no attachment defined. So there is a attachment that you need to define for any kind of behavior that you're defining through the inference objective. For now, you can define priority of the request to be served, but in future there are plans in open source to have sort of SLOs, etc. And ultimately, this EPP is able to monitor the metrics as well as to how much load is there, what kind of low rank adaptation models have been loaded, or whether it's the base layer in the model server or replica that is serving. So this is where your whole understanding of how model serving is happening comes into picture. It actually should be traced back from very much the model server to the endpoint picker to the inference pool, and then you have the decisions getting taken basically. So coming to the high-level request flow, this is where the vanilla or open source Kubernetes gateway with inference extension enabled works like. So it has the client request coming on this endpoint, let's say completions. Then this request goes to the body-based routing and EPP for kind of doing selection. Now, basically, you need to understand that when a model server has to serve the request, it really needs to have some GPU resources free so that you can have some computation done for GPU. Also, it should be able to have some sort of the queue should be free. Basically, it should not be that there are a lot of requests already in queue for that particular model server, and you are going to that model server only instead of the one which is actually free. So such kind of things you have to focus on. This is where the endpoint selection and the body-based routing concepts come into picture. These services essentially help us understand which model server needs to be routed to, and ultimately then Kubernetes gateway takes the decision that okay, based on the information that I have received, this is my pod or model server that I need to route to. And this is how the GKE version looks like, which has a bunch of other additional things. So you have end-to-end observability getting captured. So there is a custom resource called pod monitoring that we will see shortly that is deployed as part of the inference gateway solution, let's say. And ultimately, you are able to have all the observability related metrics, etc., flow to your Google Cloud Observability. Additionally, there is something called as Model Armor. So Model Armor provides the content filtering and AI security and model safety. So this is where, let's say, you have to get protection against jailbreaking or prompt injections, or you want to anonymize anything or sanitize your prompts, be them coming in form of inputs, or the prompt responses that have been generated from the backend also need to be sanitized or need to be checked that okay, whether you are sharing any PII data or any identifiable information. All those checks can actually be done using Model Armor. So there is a direct plugin here wherein you can have security related extensions, and likewise there are GKE extension processor or service extension that you can write to do some custom logic also with respect to how you want to serve. So these are some additional add-ons on top of the open source stuff. And then there are a lot of other, I would say, enhancements that recently got announced, like about 7-8 days back only when there was this KubeCon Atlanta event. There were a bunch of new features, prefix aware caching, etc., and some other optimizations that were surfaced as part of the launch. So now let's see how GKE Inference Gateway features could really help us for solving our issues that we saw in the first slide, or the changing trends that we saw. So we actually have some supported metrics getting reported, and EPP, as I mentioned, is the one which is helping us retrieve some of the metrics from the model servers or the replicas. So KV cache hits are what we are getting. So for people who are new again to this AI serving and all, I'll quickly explain what KV cache exactly means. KV, as you might have already gauged, it stands for key value, but then what exactly the key value is for. So let's say when you are dealing with LLMs, you are supplying a prompt and you are expecting some response. The response, let's say, should be the quick brown fox jumps something, let's say a random sentence. Basically, each of the words that are getting generated or the tokens that are there, let's say the quick brown fox, all these things that are getting generated, what the next word should be also needs to be kind of retrieved from the semantic information that is there as part of the response that is getting generated. So KV cache hits or KV cache utilization behind the scenes, it has 3 vectors, essentially like one vector called Q vector, and then there are 2 matrices K and V. These are getting maintained, which essentially help us with the next term, which relates to the semantic of what exactly should be presented as the next term. So KV cache hit, when we say, so key and value that gets stored are nothing but some vector or matrix representations. These representations have something related to the context that we are looking for in form of the next token that should be outputted. We don't have to really go to the mathematical formulas, etc., but you can understand that when we are generating the next word for a sentence, like we generated the and then we generated quick, after we have to generate after this we have to generate the third word. Third word will need to really process the first 2 words again and their semantic relationship before suggesting the actual third word itself. So this is where for every such next token generation that needs to happen, you have to process whole of the stuff again. The beauty of the mathematics behind the scenes is that the computation that we are having doesn't really change. So the value of K and V for every term that is getting generated remains the same. So we actually can cache the K and V values rather than regenerating and reprocessing everything. That's why you see that sometimes some of the LLMs provide responses at a much quicker pace than some other LLMs. Some LLMs are just generating thinking but some LLMs are just writing the output at a very fast pace. This is because those LLMs which are producing the fast outputs are using something called as KV cache utilization or cache-aware routing also. So that's where all the speed and optimization is coming. Like we will see this in action shortly in the demo, but we won't get into the mathematical details of this. You can just assume that there is some sort of vector and matrix operation that is going behind the scenes. GPU TPU utilization also we get to see, and then request queue length as to how many requests are there waiting for inferencing are also reported. Then there is something called as prefix cache aware routing. This prefix cache aware routing, you can just assume that okay, if your prompt matches the longest prefix out there in some model server which already has KV cache done, which one has the most matching prefix is going to be picked next, because that way you won't really be required to do a lot of computations. You will be picking up the responses from the previous set of computations that were cached. So this is where prefix cache aware routing essentially is for picking up the node which already has some computation done, so that your response generation can be made quick. Dynamic LORA, so this is low rank adaptation. This is where you have some base model, and then that base model is fine for serving a lot of requirements, but then there are some minor tweaks or opinionated, let's say, responses that you want to give, for which you train or fine tune some additional adapters and you deploy on the base model. So GKE Inference Gateway is able to understand through the EPP the metrics that it is getting and the active map of LoRa adapters that are there it is getting from the underlying processing that it is doing. It is able to see which nodes have some specific model adapter getting used, or it was used in the previous set of requests, so that you don't have to reload the model adapter on any new node. Rather, you can route the traffic to a node which already loaded the model adapter, and then you can have quick inferencing done again. So it's not just about talking on how the model inference server would work, how quantization, pruning, etc. will work. We have to think about these things as well as to how from load balancing perspective we can do intelligent load balancing so that we can have quick serving of the models done. Then we have inference oriented optimized autoscaling. So HPA profiles are there which can reference now custom metrics and model server metrics. So this is pretty much I would say a traditional thing using custom metrics, but it has been implemented with model server metrics as the metric source for inferencing. So this is where you can have the pods autoscale based on the model server metrics. Body based routing, model safety, and inference observability we have already touched upon. So this is how it could look like. The regular gateway, if we go with traditional one without the inference section, you can have HTTP routing to a service, but then we can have inference pool also considered when we are talking about the actual inference use cases. So this is where we see that this particular gateway has the hostname example.com, and this is routing to /completions. Now /completion can actually get two models based on the query, let's say parameters or the model body. The request body that is there for the model inference request that you're making. The model name could be a chatbot model or could be a recommender. Now, based on chatbot recommender, what this inference model and EPP would do behind the scenes, there could be even priority specified here, which I have not reflected. They will be routing to the correct inference pool. So for inference pool, that has to relate to chatbot. The pool is powered by Gemma model, whereas the one which has recommender, that is let's say serving DeepSeek. So this is where you can actually have the very same path, but using different models, route traffic to different backends altogether. There are other things also that you would have seen in GKE if you would have been, if you are already a GKE user, like node auto provisioner, compute classes, etc. Those kind of things also can be made to work alongside in a complementary fashion with what all I'm discussing. But today our focus is not on the capacity side of things, rather load balancing side of things. So we won't deviate that much. But for people who are really interested, you should go ahead and see the HPA, VPA, cluster autoscaler, node auto provisioner, and compute classes for GKE. Those aspects are also going to help you do a lot of intelligent serving for your models. Ultimately, what we are able to do with what all I have discussed so far is that if you see the traditional round robin serving, which is without GKE Inference Gateway with a regular load balancer will be using something like a round robin algorithm or some specific algorithm, but not something intelligent to gauge the model requirements and do routing accordingly. So this is where you see that it keeps on hitting, let's say, a node too often, that the pending requests in the queue grow like shown here, and likewise the KV cache utilization also grows. However, this particular node is free, and this could have served the request, but because the load balancer was not aware of this particular node's properties or the real-time, let's say, behavior that it is exhibiting, it ended up doing the round robin thing and ended up on this particular thing. Now, what happens really is when the queue lag starts building up, sometimes the lag is so much that many of the requests will get dropped and will be returned as 429. Sometimes it happens that the underlying server itself will be running out of GPU, and hence there will be memory kill. So there will be a lot of issues if you go with this traditional routing model. However, when you get to the GKE Inference Gateway, because you have prefix cache aware routing, because you are considering the KV cache utilization metrics, because you have LoRa adapter related intelligent routing, and because of all the other great features that Gateway API has to offer in addition to what Kubernetes can offer, you are essentially able to route the traffic to the one which is least utilized. So now you actually get to efficient utilization of GPUs, and you are not even keeping your nodes idle. So this is where it's cost optimization, and we have seen in scaled use cases where enterprises are using GPUs extensively, that when they switch to such kind of a model wherein such intelligent routing is happening, they are able to accommodate more requests with the same infrastructure rather than having to scale pods. Because generally what you would do is in the traditional routing, you will see that there is bottleneck without doing let's say deep study as to what exactly is becoming bottleneck. Most of the people will go ahead and shoot up a new replica or a pod, or probably bump the HPA count to, let's say, 10. They will think that okay, HPA threshold is something which is becoming bottleneck, but the actual thing is that the bottleneck is the load balancing itself, not the HPA. And for that, you need to do a low-level study. However, in this particular use case, your HPA also can respect the thresholds that you are setting on the capacity for your pods, etc. So this is where a fair scheduling can happen, and this is where you will see a lot of, I would say, benefit coming when it comes to routing. So let's start with something called a GK Inference Quick Start. So this is a utility which is available, which can give you recommendations on what exactly could be fit as a model for you. So here you see that you have gCloud Alpha Container AI Recommender API. Now this is a CLI that is available that you can use, which is depending on your model requirements, telling you which model has what, let's say, normalized time for first like TTFT or NTPOT, etc. All these output time or input time or time to first token related metrics are getting shown to you by model. So this is where you can actually go ahead, use the CLI for getting an understanding as to which model will suit your SLA requirements, etc., your serving requirements, how the performance would look like. And ultimately, through the CLI, you can even generate the manifest like I generated, and you can apply. So you can see that I have got the kubectl outputs now for the manifest that got applied. So I'm getting the pods, I'm getting the service, and I'm actually getting all the additional resources like HPA, etc. And now once the pod status shows as ready, which I think should be showing now, we are ready to serve our workload through this particular model. So this GKE Inference Quick Start is a very good CLI tool. It is also available on the UI if you are using the GKE console, for you to go ahead and pick from the list of models. The models will show the performance insights. They will show how in the benchmarking they performed, and you can see how much is the time to first token, how much is the normalized time to the output token, how much it is taking for it to serve, let's say, heavy under heavy conditions, etc. All those things can be done. So this recommender CLI is really a must-have if you are just getting started and you are not that experienced in choosing your specific models. Then we will see another demo. This is where we are having the inference gateway deployed, and I have done a kubectl get on the gateway just to show this particular gateway has 6 model replicas that I'm routing to, and basically you can see on the left-hand side the KV cache utilization is for a regular load balancer which is doing round robin, and on the right-hand side of the divider you see the graph wherein the KV cache utilization is looking steady. So now for these 6 model replicas, I can see that there is a lot of I would say unequal utilization of KV cache on the left-hand side, but on the right-hand side all the nodes are essentially having almost the same KV cache utilization. You can see the graph is pretty clean on the right-hand side. Now because of this, if you look down, the average queue size on the left-hand side has gone with some spikes. So you see that because some of the nodes are getting overwhelmed with the request because it's a round robin thing that we were seeing in the diagram, the average queue size of the load balancer based routing is shooting up, and hence that just means that there will be delays in serving the request. So I'll just move down and I'll show you how it shows up. So you see the average queue size. So there is no queuing actually happening when we are doing KV cache in this particular demo. So we had like 300 QPS done, and we prepared the load and we had this experiment done. And this is where you can see that the queue size essentially has gone. So there is no queuing actually happening, because of which the time to first token also will be pretty quick. So you can see that all these time to first token latencies, etc., are pretty less as compared to the load balancer option. So right side is more optimized for serving inference use cases than left hand side. Right side is what is getting powered through GK Inference Gateway. This is just one example. There are that you can go ahead and try out. And likewise, the time per output token and the NTPOT related details also, you can see it's much better when it gets to the GK Inference Gateway. Let's get to the next slide. So we have talked about the GK Inference Gateway, but I'm towards the end of this particular session. I want to highlight on some of the other stack optimizations also that you can do beyond GKE. So this is where we will get to a 5-layer framework. This is like the edge gateway layer, the first layer, let's say, which is towards the furthermost point when the client hits. Then the serving platform, the model runtime ecosystem, the model itself, and the hardware. So here, before GKE gateway as well, you can have some sort of API gateway management solution like Apigee deployed. I'll show you one example as to how it is helping with semantic caching for use cases wherein semantic caching could be useful. You could enforce security. You can have CDN, web application firewall, recaptcha checks, bot detection, and whatnot. All these done at the load balancing layer. Then you have an option. You don't have to necessarily use the GK Inference Gateway. You can go with Inference Gateway, or you can go with serverless, or you can go with, let's say, Ray distributed training on GKE, etc., or Ray serving, inferencing, etc. All those things can be treated as your serving platform behind this edge gateway stack. Once you have decided your serving platform, then you can decide what your model runtime would be, whether it will be VLLM, whether it will be, let's say, Titan or TOTServe. You can really have those kind of things also tuned as part of the gateway. So if you want to do with regular Kubernetes inference gateway or the extension, you want to switch from, let's say, VLLM to Titan, then there's a Helm chart in which you will need to supply your preference for the model serving layer, and you can switch from VLLM to Titan. But there is something called as LLMD related project also that is now in open source, which you should check out, which I'll not be able to discuss as part of this particular session. That is for high scale, high performance inferencing, wherein you can have a lot of other factors also taken into consideration for the model runtime and model serving layer. That's called LLMD. And this model layer, if you are not really serving self-hosted models, or even if your self-hosted models are backed by storage or Vertex, let's say, you can really decide how you want to have the storage for the same defined. So sometimes you can do fuse operations using Google Cloud Storage Fuse, wherein you can have mounting on your pod done for any kind of, let's say, checkpointing requirements, etc. Sometimes you have to do a lot of management in terms of common data across different pods. Then in that case, there are other storage mediums also available, like Hyperdisk ML, or there is Lustre now available for POSIX compliant related stuff. So all those things you can get into. These are like some, I would say, stack related terms and features or product areas that I'm talking about, which can be your go-to things for exploration after this particular talk, if you really understand GK Inference Gateway. And then ultimately the hardware layer, as I mentioned towards the beginning, you should be checking out NVIDIA multi-instance GPU. If you have already checked that out and you see that hardware driver related changes could be cumbersome, or if you think like you want more software control, you can check out the HAMI declarative device plugin, or probably wait for some time. There will be a dynamic resource allocator related resource also, which HAMI is coming with. So it will pretty much look like the persistent volume claims that you make. You can make claims for GPU as well through DRA. That is something which is in open source. I don't have the ATA for the same. The maintainers for the same can be checked out with for the roadmap for the same. So go to the HAMI project, check out the DRA stuff, and you can open bugs and issues there. So ultimately, I'll now show you an example where Apigee is also in the loop here. So I'm just going to make a request from this chatbot that you see. So I'm going to ask questions which are semantically co-located, let's say. So I have asked the first question, why is the sky blue? You will see on the right-hand side that the debugging session will have the request registered. It is taking 2806 milliseconds. Now I'll just go ahead and I'll have a semantically similar query made. Sky seems to be blue. Why? And now you will see that already the caching would have happened in the background, and you see the time reduced from 2800 milliseconds to 232 milliseconds. So that's a very big gain in terms of what you are serving. So you actually did not have to go to even GKE. This particular stuff was served from a semantic cache or vector store, and this was purely done via the API gateway management feature. And in this particular specific example, we were using Apigee as our API management solution. So with this, these are some of the additional resources that you can go through. I'll be having the deck shared, so you can copy these QR codes, or you can just hit the links from the deck. And with this, I'll be concluding the session, and I'll be open for question and answers. For people who want to participate in a quick survey as to how this talk went, or whether you learned anything useful, or you have any feedback, feel free to fill in the went, or whether you people who want to concluding the session, and so you can copy these
recap, I'm Thuy. I'm based in Singapore. Currently, I'm a developer relations engineer at Google. That's right. The documentation, of course. And with that, thank you so much. I'm going to pass the time back to Bill. Thank you, Bill.
Computing have worked with Slurm. This is also one good lab that you can go with. If you're looking for some orchestration, there are even Ray or dynamic workload scheduler related links. These are all self-service in form of self-service.
AI Studio, go ahead and scan it. You're gonna have fun trying all the different, all the different factors. Scanner, if
AI Studio registration. Meanwhile, I'll show you something really interesting so that you get something outside what we discussed in form of self-service labs. So there is something called a GK AI Labs. This is a site for which I'll be putting in the link. There are self-service labs that are available for different kind of categories, and there are even things like agent blueprints and notebooks available. So for the notebooks, like you can really go ahead and see things like how to fine-tune Gemma 3 on some specific machine type and do a layer 4 kind of pooling, etc. You can do GPU TPU experiments. You can even play with job schedulers. If you are into high performance computing, have worked with Slurm. This is also one good lab that you can go with. If you are looking for some orchestration, there are even Ray or dynamic workload scheduler related links. These are all self-service labs that you can go with. Likewise, agent related demos, etc. are also available. There are blueprints that are available that you can go with, like how to use a RAG in this particular use case, which is powered by the GKE architecture. Pretty good self-help guides are there. So I would really encourage for people who are getting started or even people who are tenured. This is a good place to try out things. These are really good labs available. Okay.
things strategic around this first principles thinking and systems thinking approach. And first principles really is, all right, you take whatever situation you've got and reduce it down to its fundamental truths, separate out assumptions and so on, really get to like, what is it that you're really trying to do? What is it that you really want to get out of, rather than what may have organically been created around culture and this is the way we've always done things and so on. Get right to the core. So when you reduce it down there, then the systems thinking approach, which is different from breakthrough thinking or design thinking, breakthrough being move fast and break things, the Zuckerberg way, or a lot of, over-indexed by tech entrepreneurs who don't care about regulations or so on. That has costs. Design thinking, when you also design for an experience, whether product or customer or whatever, or a system experience and so on, that too overlooks other interactions and so on. Systems thinking says everything is interconnected. So how do you take all of those core truths that you did, decompose from first principles, and you build it in a way that now you want to get those feedback loops, self-reinforcement loops, make it where you're building a better system that is optimized to improve over time, to get better by itself. And once you've got that, then you operationalize it. People play an important part in this. And this is where there's this notion of talent density. Talent density, generally a simple way to look at it is like, okay, if you've done it right, what's the revenue per employee? The revenue per employee at Netflix is in the many millions, somewhere between 6.5 to like almost 10 million per employee. And that's not unusual. There are a lot of companies, like we talked about Whirlpool a long time ago here on this call, where, as they've reduced themselves, they only have a handful of employees. Another company I'm talking to, Dolby Laboratories, the sound company, they only have 2,000 employees, and they're more of an IP shop. The revenue per employee at Dolby is similarly very large, despite it being more of a legacy company. Power utilities, power providers here in the US, very high revenue per employee. But you use that not as a metric to just sort of build your business, but more as what's the right kind of person you get, and all of that. And I know we've come beyond the elevator pitch, but like put it all together and you get what is an AI native company. Is you trying to build, well, there's a lot that goes into it. Like, okay, so now these are sort of the structural, strategic things that you need to have in place in order to become something more AI native. You basically want this grand notion of you've got one person who's orchestrating with a whole host of very fully connected, interrelated, whatever, AI agents. So they're able to do a lot more. And in an environment like that, if you get the right person, they're not going to say, oh yeah, I want a 3-day or 4-day work week. No, these are people who are still going to be working, but they're going to be working so hard, your business grows, and hence you get that higher revenue per employee metric, et cetera, et cetera.
So systems thinking, which I partially understand, it's a very broad word, use of the word systems. I think I get that. The systems thinking plus talent density equals success. But my God, how can existing companies move in that direction? That's crazy talk, man.
Yeah, I boil it down actually to
I remember your formula. Yeah.
Formula.
I was partly saying it. Yeah.
I was just trying to pull that up, and
yeah.
But exactly, it basically is your hold on, I'll share it. Give me a second.
Sorry, guys, we just started because so many people it was kind of coming in later. We just started on a discussion with Mosh. He's doing followed on with his OpenAI presentation and did another presentation is further refining his strategy and philosophy um, for business. I'd say business re-engineering to some degree.
To some degree, yeah.
Yeah.
Here.
Because you're talking with people in large corporations that exist, so I don't know how to think about it any other way other than.
So if you guys can see this, it really,
Right.
we try to get to that exponential growth. It is that notion of talent density and AI leverage raised to the power of your learning velocity. And you can see even in my notes, my speaking notes in the bottom, talent density is exactly as I sort of tried to say it. It's being able to get sort of the right kind of people who work better with AI. The AI leverage, as I've defined it, is sort of that ability where AI amplifies your capacity to produce something. So you're making widgets, now you're making AI helps you make exponentially more widgets. And of course, the learning velocity is that organization's ability to absorb, infuse the new insights that you get. So you're constantly looking at your unbiased data, and you're constantly taking those insights and go, okay, well, here's a better way to do this, or we should stop doing that. Strategy is also the choice of what you choose not to do versus what you want to do. All of that, and you just kind of boil that in. And
so I would say what you did is you reversed engineered the most successful, the new instantiation, the new instantiation of success, which are certain companies. But so now your next step is to apply it practically, and see if it can be used to you know, whether it's a startup or it's kind of natural to a startup, but but whether you can actually take this formula and apply it in a way that moves companies in that direction, right?
100%. And it's true. I'm not coming up with something original. This is really looking, and all of us, academics and so on, we look at the patterns of successful companies. So right away, there is a survivorship bias. These are the companies where it worked for them, and you don't capture easily the attempts by other companies that also try to do it in the same way, but for whatever reason, maybe just misfortune, bad luck, they weren't successful.
So a couple of comments. I think one is, do you still have a link to your presentation? Can you post that? And yeah, you can do that after later in the call if you'd like. Sure. The other one, Yuri said that's not an exponential.
So that was no, but like more seriously, which part of it you think is exponential? Like what would
the learning velocity? The learning velocity is that speed at which the organization absorbs feedback, adapts, and improves. It's measured by how quickly the teams can iterate, how fast AI models retrain, and how often those insights are shared across domains. This is what you use as sort of the exponent in this heuristic.
Yeah, I think the point is not exponential. The point is to the power of, and that to the power of just like affects the whole equation to a huge degree. Would you call that something else, Yuri, than exponential? The reason I surface this is because there'll be people in your audience. Most of them are business, so who gives a shit, right? But I thought it'd be interesting.
No, but I'm kind of looking at it from perspective like to me, velocity is like that agile velocity of like how fast you develop. That usually is constant. You can't really go faster, right?
Mm-hmm.
Maybe with AI you can, but organization goes slow.
If you think of it that way, and because this is a heuristic, if you say learning velocity equals 1, that just says a very simple organization that only reacts in a very linear manner to you learn something, you do something about it in due time. But a 1.5 or a 2 would be you learn something and you preemptively or proactively act on it. And there are organizations that we can all think of that are really good at infusing lessons learned. We made a mistake. We're going to do everything possible that we don't make such a mistake again, and we're going to correct things quickly.
I mean, that almost engenders you working with small teams of smart people. And also the other thing is, this is also just really also part of our times, because when things are changing in the way they're changing, and like tomorrow you get like, a new MCP capability you didn't have 2 days ago, like like processing outside of the context window, like doing that shit. You learn that and you bring that to bear the next day. And because you learn that in a day, all of a sudden you could do like 10 new use cases open up. That happens like every fucking week if you're paying attention, right, Mosh?
Yeah.
So it's part of the putting learning as an exponent, I think, Yuri, is that.
Okay.
But still, I don't think that answers your question totally. Yeah, go ahead.
No, but that's super useful. Now I understand this,
And then
I do think a fundamental part of it is what you said, though, Yuri, is that like what I've seen with like what's her name? Teresa Torres, interviewing small teams that have successfully put AI applications into production with their customers. They do it with like a team of 3 people, do like 90% of the work. A product manager, one tech person, another, and they represent this equation. So you're not, you know what I mean? So like the Scrum and the, that all that stuff, none of that means much if you have 3 people and it's a teeny team and that's it, and they're working hard together. It just makes this an explosive equation, really. So
there's also,
anyway,
one final thing: the choice of the technologies that we make. If we start adopting everything, we're the first adopter to something. There are popular platforms today that in AI that basically only do RAG at scale. But they can't do anything more than that. And so if you went through a whole bunch of effort and changed your company and everybody's got to do it and use it and you deployed it, all of a sudden you get newer capabilities that further enable AI orchestration. But that other platform that you went through all this effort to now put in, you're stuck with it because it can't do orchestration. It just does retrieval. And so you're stuck. You spent close to $100 million on transforming your company doing this, but to do AI capably because of the new innovations, as Darren just said, you've got a new MCP and all of that, and now you can actually do orchestration and actually have it do the automation stuff that you had originally wanted, but you're stuck with this older technology that you just installed less than a year ago. But the industry, the tech stack has moved forward.
So that's exactly what we did in our company. I was not involved, but our VP of AI did that, build RAG. But actually, it just becomes a tool now, and a useful one, because it's RAG on our internal, on our content. So it actually just becomes a tool part. But let me ask you, so Yuri, though, this is what the way we're talking. You're talking about Amash like it's for everything, but I don't think this formula is as applicable to like Yuri, the stuff you guys are building, right? Like, because it's not like this new wide open field where AI is offering all these affordances, really, at the core of the risk models you're coming up with. It's almost, I don't think this equation applies.
Yeah, and the reason I'm curious about it is because I'm now have to kind of defend our technology, and all the questions are, well, where is your AI ML usage, right?
Mm-hmm.
Yeah, you're doing statistics mainly, right? You guys are almost like underwriters. You're doing risk analysis for energy, generation companies, and it's at best it's because there's going to be some machine learning in there, but the agentic AI stuff is really maybe just for explaining to customers or generating reports, right? It's on the edges.
Well, there are a lot of like stuff around it where
but it's not at the core, which means you don't get this machine that Mosh is talking about. But then I would think Mosh would say, I don't know, you got to build an org around systems thinking, but is there really that sort of virtuous feedback stuff in that world? I don't know.
you do have to build that org. So you can't just throw systems and technology at something without focusing on the other equally important half of the equation, which are people. You're going to need to evolve your people just as you're evolving your tech stack. This is a controversial point. There are multiple schools of thought of how you even do this. I mean, do you let go of all your people, or do you take your existing people and you give them the AI literacy, or do you replace all of your headcount entirely?
Yeah, but in reality, what they're doing is it really is return to office is a convenient way of just letting that happen the first phase of it, because you get rid of a lot of people that way.
Yeah, I'm not. I can't speak to that.
I mean, from a mechanical point of view, that's what's happening.
Well, that's just reducing headcount then, and you don't.
Yeah.
But then again, it still doesn't answer. Okay, but then
let's talk about Yuri's situation though. So Yuri, do you guys really have any way to increase the human element of this? I know you've tried. You got interns in. I mean, like, how would you really do that, Yuri?
So for us, like actually narrowing, maybe focusing on like coding itself, that's probably like a good use of AI for now.
So leveraging
in addition-
AI with people who are
Yeah.
so like AI first coders would be a good thing for you guys to get,
Yeah.
like someone who really, I see. There you go, Mosh, there's a piece of it.
And that's the other thing is like you replace. Then you're changing the job description, and this is how you would do it legally. You change the job description, and then you say, well, your existing people, whether you incentivize them through RTO or whatever, that they sort of leave, or in re-interview, or you have external people interview for those new AI native, AI coding first role, technical roles or whatever. And really, you kind of also have to focus on, to do this right, you need the AI tool efficiency sort of as a T-shape along the vertical, and the horizontal much longer is that domain expertise. You are not, and this is my opinion, so I'll give you that caveat, take it for what it's worth and take it as skeptically as you want. You throw AI enablement at IT, this is a company that I will probably, just bet against it, because this is a company that's going to fail very quickly. Or at least they will struggle competitively. You want all of this to be enabled by the domain experts, and that has to be deep. That means if you're going to enable anything in people operations or the organizational operations, you're going to need folks in HR to be the ones configuring the AI, building the AI. You're going to do something in logistics, global logistics and supply chain. Those are the people who need to be working with the AI.
That's all of that's the fucking truth. I've experienced that shit firsthand.
If you throw this over to traditional IT, information technology, those folks, in my experience, hardly know how to do information or technology. They'll chase shiny new toys, but they won't know how to adopt it capably.
Well, they need to adopt it for themselves and for the work they do. Really,
Right.
That's what they should focus on.
One of the Mhm. 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 Yeah. Yeah, and Europe. I don't know if any European friends on the call, but Europe is another example. And I was having a conversation with a close friend of mine who is in the US, but remotely leads sort of the knowledge and information part of an sort of auto mapping company, one of the leading ones globally. And he and I talked exactly about this. His challenge is those European organizational styles focus more on culture or control, just as Mayank said, and that because of that control, there is that forced deference. Whereas in order for you, from a theoretical standpoint, in order to do that systems thinking and talent density, all of that to work, you can't have that. You need to have strong people across the entire organization who can speak truth to power. That's the only, because you're going to have tensions, and you're going to have to turn those tensions productively. Those productive tensions are absolutely important in order for you to get that learning velocity and the AI leverage and all of that, the mechanics of it. So having the right person, right teams are absolutely important. But if organizations, as Mayank just described, inherently don't allow for it, you're not going to get this kind of exponential growth that, as the data shows, the United States seems to be over-indexed. Silicon Valley companies tend to be over-indexed on that kind of exponential growth.
By the way, I see this conflict every day on my job because we were bought by Informa, who's a European company, and they're all about control, and they blocked everybody. So from you have to ask for exceptions to get the ChatGPT and things like that. And so like this is huge contradiction because really the fundamental value of generative AI is in that individual use case, right? Like you no longer put a final layer on a BERT model and train it for a classifier. Those used to be the things you could do. You know what I mean? But now the things you can do are freaking infinite, and they take love and care to make them actually be beneficial for the individual or for the department. And those two things, control and then where the real value is in the individual acting individually, are in huge contradiction. And I don't know how society is going to resolve those. And everything's fucking crazy. And there's going to be a big AI backlash, I think. Riots in the streets, man. I don't know about that, but I feel like something's coming.
I don't think it's because of AI or anything, but
I don't know. Politically, it's gonna be very political soon. And yeah, I mean, there's hatred out there. Like I had a call with 70 people. They had me, I have an internal call a little bit like this that I've had for a year. And then they want me to expand it out to like 100 and something people. And I did a word cloud that people could put in key phrases. And most people were pretty good, but someone put in there like all these horrible anus phrases. Like fissured anus. I'm like, what the fuck? So there's sabotage and there's a lot of hatred. There's a decent amount of hatred and concern. But I'm saying part of it is that conflict, right? Between the fundamental nature of the technology being where the value is. You say domain expert, but I would go even further. It's really in that individual's use cases, and everything grows from that. It's like growing a garden, right? It's that little fucking seed and really nurturing that little seed. That's where the total value is from all this, really where it all stems from. At the same time, there's this level of control that also comes from it, and I don't know how it's going to reconcile itself, but I'm
I
living
will-
it.
I will say there are outliers. You can have outliers. Even when you have rapid control. So today, if you all follow Consumer Reports rankings of automobiles, number one this year, once again, is Subaru. I've had the distinct pleasure of working at Subaru, worked on the machine learning models that went into the engine assembly process, working at the plant, and so on and so forth. And I've had the distinct pleasure of working at General Motors, Factory One, and the plants and everything that I had access to, supporting the leadership team. At Subaru, it is owned wholly by Fuji Heavy Industries in Japan. Fuji manages various classic control. They will not allow more than 10 months worth of data to reside in the US. Not a full year, 10 months. That's it. You cannot build any seasonal capturing, like any kind of predictive models, any of that. Not allowed. There are people from Japan that make sure that none of that stays in the US. For the Subaru of Indiana Automotive, the assembly plants in the US in West Lafayette, Indiana. And the place is run, even my engagement 6 years ago. What a beautiful factory. 2 major assembly lines pushing out all Subaru vehicles assembled here. Absolutely clean, and a beautiful interplay, even 6 years ago, between robots and humans, putting it all together. 100% of all Subaru vehicles are rigorously tested and checked before it leaves. Unlike the American automakers, which is a small percentage to get it statistically relevant and so on, that are actually tested before they come out, the other American brands the factories are dirty as hell. The Japanese are very much, you keep things clean right away. When there's a drop or something or whatever, clean it right away and keep everything like there's no dust, because you proactively just make sure it's when you
what's the outlier story here?
That's the outlier. Your control. If you're like Subaru, which has this tight control by its parent company, Fuji Heavy Industries, and you can still build a product that ranks number one in Consumer Reports of all vehicles out there, followed by BMW, the ultimate driving machine.
Are they able to use more than 10 months of data?
You only use data just as you only need it to. Pretty much, okay. Fuji controls how everything is done and operated in the assemblies lines in the US.
So the outlier you're saying is that the centralized control can work?
The outlier is control, not even central. I mean, it's not centralized. The parent company controls everything.
So most companies don't work like that, you're saying?
Most companies don't work like that. The other automakers don't work like that. I mean, all the way down to, there was no garbage bins necessarily. Even I still have my water. I mean, you're supposed to have this big plastic, everybody carries their own plastic, this water jug, and you're supposed to drink water that way. Everybody had it, and I should bring mine out to my locker here. But yeah, control can work, but you have to do it uncompromisingly.
Yes, no, I get the point. Okay, guys, so look, I think maybe, does anyone have any last comments on any of this? Because I think we'll wrap it up. And Masha, I want you to remember to put a link to your presentation, right? Yes. Okay, when we're done. We've been talking for a while. I just want to remind you. And does anyone have anything else to say before we move on and start collecting other shares? Okay, so let's just do it this way. Is there anybody who has, top of mind share that we could start with? Updates from Alan. Do you have updates for us? Or Sam, you've been at some conferences, you just something you want to update us on, or Yuping, you've been doing any work with agents or something? I don't know. Does anyone have anything they want to share? No. Oh, interesting. You're not talking about ADK. You're not talking about ADK either. You're actually talking about the deployment side of it, the agent engine. That's separate from ADK, right? Does anybody want to pull that thread more and look at some of this, or a particular aspect of Vertex and how the Vertex platform is enabling agents, and particularly agent engine and how it works and so forth? Is there anything anyone wants to look at further with that?
Well, I mean, I'm not ready to present anything, but I'm really interested in, gravity,
Anti-gravity?
anti-gravity, yeah, and the new Gemini 3. I'm thinking once I get my my forever release out, which is really close, I'm gonna probably try to just take a refactor and see if I can use some of that. Some of my other peers have said that's pretty amazing.
Has anybody looked at anti-gravity at all? I haven't even glanced at it. I've just been hearing about it a little bit.
I used it even in last night's presentation. I was using anti-gravity of running my notebook, but honestly, I use it the same way like I use any other IDE. I'm not doing anything different. It's just another ID.
You want to show a couple quick? Do you want to show a couple quick things in it, Mosh?
I don't know anything quick.
Sorry.
Like you put them side by side, with cursor, and it looks the same to me.
Okay, that's good to know.
Well, yeah, that's kind of what when my little bit is the same. I get the same ideas as Mosh, but what I've heard is that if you go down the agent rabbit hole, it can be better. So I'm gonna try that and on my whole code base and see what happens. But in a separate place. This is a test, right?
Do they have a dedicated model, or I mean, like maybe one advantage is also that you're going to get more tokens from Google. Like at this point, that could be the advantage of the IDE. I don't know.
I mean, I guess a Google AI Studio. If you do Google AI Studio /build or something like that, you can get free token. You get some free tokens to play around with it. Anyway, I don't know. I mean, I understand what you're saying. It kind of looks the same, but I guess I don't know. I'm buying the hype, right?
But is it? It's just it compares to. I'm sorry. Go ahead, Mike. So in AI Studio, when you say build something, you can build, what do they call what you build? Are there little agents or apps you can build in AI Studio?
Yeah.
So I've only actually used it for just, prompting the playground. So. And in fact, this is what's interesting about anti-gravity is like all of these IDEs are catching up to each other to some degree. But what does Google have? They have not just, they have all the Vertex AI stuff and a bunch of other AI stuff. So handing off back and forth. And then is there any visual tool yet from Google for, putting together a workflow or an agent without coding? Because once they can do that and you have the ability to go back and forth between them, like create it there and then code it in with ADK, in anti-gravity, you can like almost do everything and then deploy it into the agent engine. It's a lot of different interoperative tools that would be amazing. Yeah, there is, but it's not integrated into anything yet, I don't think. Okay, but part of the point is when you're an enterprise, you want people at the edges there, the domain experts, to be able to create those, but then you want, so I'm sorry, show that again. I was just looking. I wanted you to finish up to do that. So show me how you create something and hand it off. Yeah. So you could chat and alter it. So you're going to vibe code. Right. So this is just like the pattern you see a lot where over this past year where people use Lovable or Bolt or whatever just to just get something up and going, and then you take it and put it into VS Code or into Cursor actually. And then yeah, so that's the same workflow. Nice. I didn't know you could do that. I think Google has a really good play with the IDE because of all being able to integrate it across they're different tools. It's going to be pretty good. Very good. Any other thoughts on anti-gravity, Vertex, etc.?
Just to be that guy, I will say that I tried out anti-gravity when it first came out, and I mostly was trying to replicate a lot of the the tweets that I would see, hey, one shot this game or app or something, and folks would show this beautiful thing that it one shotted, and that was not my experience at all. Um, I tried to have it one shot a pinball game, and like it didn't work. And I spent a little bit of time trying to get it to refine the prompt and get it to work, and it never really worked. So it just kind of seemed like an IDE, like everything else. And it really made me question when you see folks like on Twitter saying, "Hey, I one shotted this thing." If they really one shotted it, or if they were just spending a lot of time to make a nice tweet.
I also had that similar experience with anti-gravities, and though I think that maybe the ability to become like one shot and build something correctly it's probably like people who try it later on will have better experience. And one thing and I haven't tried extensively all the all the new Google offerings. One thing I noticed about the AI Studio is that it sometimes it would actually refuse to do certain tasks, even just like very very straightforward, like give me the Python version for something. It would just like it would just like flat out reject doing something.
You're talking about a prompt in AI Studio?
Like the Gemini's like the Google AI Studio, for example. So yeah, so there's like just like a varying level of experience depending on which interface used to connect with the Gemini 3, whether it's anti-gravity, the AI Studio, or chat Gemini 3 chatbot interface. Yeah, so I have not found like a very consistent experience across all of them.
What are your overall thoughts about Gemini 3?
Yeah, so once I try those things, and then I realized like I'm facing some limitation. For example, like in Google AI Studio, I would say yeah, it's able to one shot an app, but then to really get it to work with services, then I need to understand some of the back end, but then it refused to do back end in a certain way. And I'm sure it's because like, you know, I want to dig into how to go around it or something, but then my first response is that if I really need to get something working, I would just revert back to some tools I already know. So yeah, so I don't know. That's kind of my experience so far. I would be curious about maybe people are not running into these things.
Anyone else have any Gemini 3 experience?
No, I don't have any current experience, but I'm gonna try to get some. I think is the point. Like what I'd like to do is take my architecture and even further agentize it and MCP it, so to speak. And like, for example, I have a batch run component, and I'd like to make that a MCP kind of agent. It makes more sense, but I haven't done it yet. And so when I do it, I'll report on it and tell you how it goes. Right now, I'm just using Cursor and still doing my vibe coding and planning, and you know,
Getting good. You're really probably getting good at your skills with how to break down the problems. And
yeah, you know, you got to use the right words to talk to people. You actually have to talk to this thing in a way it can understand, right?
What's funny to me is 10 years ago, engineers go into engineering jobs so they do not have to find the right words to talk to anything. And now it's like the core of their job. They're like, where am I? What world am I on now? Oh my God, I didn't sign up for using the right words.
Yeah, I mean, you know, through the years you work with a lot of different people, and one kind of person I work with, which I've always admired, is the person who is an engineer, and they're brilliant, but they basically build everything from scratch, and it works. Even in an organization, it works because they do such a good job and they understand it so well that you know, it's like amazing. I don't do that, but I am always amazed at how well they can do in an organization, right? You know, oh no, I made my own compiler. I did this, I did that, and that's like, oh, okay.
Well, I think what you're referring to, Alan, is the tech bro, the modern tech bro. So tech bro of the aught years and so on was, you know, from the HBO TV show Silicon Valley, all geeky, nerdy, and so on, and they did it. Now in the 20s, what we found are the tech bro, the tech sis, is someone exactly like what you described, with one extra crucial ingredient. They are singularly ambitious and ruthless. So the classic tech bro, tech sis, according to the San Francisco Chronicle, that did a all deep dive, brilliant research on it. I'll remind me to find that article. They found that it's like Travis Kalanick, Mark Zuckerberg. They are the classic ones. They know how to code. They're building it, but they are more like strength of personality can bring everybody together and everybody falls in line. Somehow magically also you do the whole, you know, Silicon Valley mindset of how the company should work and systems thinking and all that. Reed Hastings was also someone like it, but probably less technical, but really understood people more than anything else and the business. But the modern day, like you name the company. The one exception is there was a survey done of who you want to work for or who you respect if you're an engineer. The person who did not come in any of the rankings was Sam Altman. Nobody in Silicon Valley seems to like Sam Altman. But they all,
Did you just say Sam Altman?
yeah, Sam Altman.
I know.
Everybody wants to work
He's
for,
become so distasteful.
yeah, which is, you know, kind of sad because I think he's a decent guy, but yeah. Yeah. Yeah, Johnny Ive. Perhaps, perhaps, but I think in broad sense, the leaders that folks gravitate to seem to be the Elizabeth Holmes or the Mark Zuckerbergs, or better or worse.
Yeah.
This is I'm just curious though, like the tech bros or the tech sis,
Uh-huh.
it's like a survey across in Silicon Valley though,
Correct.
not like outside though. Yeah, so
Mhm.
there's I wouldn't describe it as a bubble, but maybe that perception would have been different.
100%. 100%.
Yeah.
Yeah. There is certainly that bias.
Explain it to me in general. Who gets into this? Who does this? How would I send someone from my company? Uh,
Where is the information? I don't see it. Oh, Slack. Okay. Sorry. Okay. Thanks. Well, it says you need two administrators, and you need an open source, yeah. So is that stuff that is that stuff open source, and are there two administrators? I mean, I was just thinking about my own project. I don't really have that right now. Yeah, I mean, I think the bottom line is you get funding for somebody to work on your stuff for 2 or 3 months, and they're usually pretty sharp, but it needs to be totally focused. I mean, I'm pretty sure, and because otherwise, it doesn't make any sense because you're going to be pulling somebody new in that doesn't really necessarily know exactly what you're doing. Yeah.
That's what I was thinking. Yeah. But you're trying to get yourself sort of supported and do some of that work. Is that the idea? Are we done with that, or was there something else, Mike? Okay. I don't know, unless anyone has, we're such a small group today, unless anyone has a strong feeling about something they want to talk about or ask about or share. If you do, say it now, otherwise we'll call it a call. But I'm just going to sit here for a second, see if anyone has. By the way, Mash, thanks for keep sending those. Those are interesting articles. I'm opening each one.
Of course.
So that I can read them later.
All the links you asked.
Yeah, thank you. So does anyone have another area that they want to show, share, talk about, bring up, or we'll call it a call, maybe? Hmm. Uh-huh. Good. And if you have something to show us on, if you do more experimentation with Vertex with the agent capabilities, you want to show something next week, that would be cool too. Yeah, that's good stuff. Okay. Anybody? Anything else? I think it's okay to have a short call once in a while, don't you think, Mayank? Okay. Yeah, the 5th is the new 25th. I'm just Mayank's going like, you're not part of the talent equation, dude. So, but yeah, I know things are between now and the first week of the year, it's hard because there's so many people at work. There's so many people that are taking vacations too and stuff like that. So, all right, that's cool. Let's just call it a call then for today. Okay.
All right, thank you a lot.
Thanks, everyone. Talk to you all soon.
Have a
Thanks, Mike. Bye.